Hello everyone. In this video lecture we will discuss the solution of some numerical problem, particularly the numerical problem given in the assignment second, problem 1. What is the problem? The following data set, we have this following data set and we have to find the decision tree. Okay, so here this is the problem detail. The following data set will be used to learn a decision tree for predicting whether a mushroom is edible or edible based on the shape, color and order. So we have to calculate these three things. What is the entropy of edible, whether it is edible or not, given that order is 1 or order is 3. We can see order is given in terms of 1, 2, 3 value attributes, and then what will be the root of decision tree and the full decision. Basically all these three are simple part of the same problem that we have to find the complete decision tree. So if we recall the theory, what is entropy? Entropy gives you the uncertainty in the information. Okay, so entropy can be calculated as this, like in terms of entropy of certain attributes with the value v. Attributes can have value v1, v2, v3. So here it is the probability of vk, that is probability, it may be v1 probability of v2 and so on. So the probability of a particular sum, here it is summation of all the values, for it is for this expression is sum for all the values, and within this single expression we have the probability of a particular value, and then we have log 2 of 1 upon probability of the same value. This can be summarized as this. This is the formula of entropy, if you recall the lecture. Now the special case of entropy is where the value can take only two binaries, whether it is 0 or 1, yes or no, binaries value. So this entropy formula reduced in the simpler form like this. Here the Q is the probability that for particular one value. So as it has only two value, so 1 minus q will be the probability of other value, right? So we can see this decision tree. Here shape, color and order are the three attributes. Shape can be given in C, D, C, so we have only two values, and color B, W, G and again B and W, so B, W, G and U, sorry, the four value. Order is given 1, 2, 3. So order attributes take 3 value, color attributes takes 4 value, shape attributes takes 2 value, and we can see the output has only 2 values. So we can apply in this problem the formula for this B Q, right? So how a decision tree is calculated? To calculate a decision tree, we decide the priority of nodes, the priority of some particular attribute. How important is particular attributes in making decision? We calculate it by information gain. Calculated by information gain of particular attribute. Information gain can be a gain of attribute A can be written as H goal minus remainder A. So what is H goal? H goal is basically the entropy uncertainty, that is entropy of this output. So what is the entropy uncertainty in whole data, right? What is uncertainty in whole data? This will give you, this is given by the H goal, okay, and minus remainder A. So once A is the attribute, once you decide that particular A values after deciding means you have taken decision that A has certain value. After taking this decision, how much uncertainty is there? So this is the remainder uncertainty, means uncertainty after you have decided the value of A. This is given by this remainder value. So H goal is simply B upon P plus Pn, that is P is the number of positive values, we can say positive, negative or whatever, and suppose it is the positive value of yes, P is the positive value, what we are deciding whether it is edible or not. Yes. So we can here the yes can be, number of yes can be the value of P and the number of no can be the value of N. So here it is simply the H goal is simply our P plus B of P plus N. And what will be the remainder value of remainder? Now try to understand this. This is important. It is once you have k is equal to 1 upon sum from k is equal to 1 to d. What is d? So suppose we have decided that particular value A, we take A for decided. So A has this, A can take d values. For example, here shape can take 2 values, color can take 4 values, order can take 3 values. So here for shape d is equal to 2, color d is equal to 4 and order d is equal to 3. So for particular value, say for example we take shape is equal to C, what will be its probability? Basically P plus N, as we know P is the total count of yes of the output and N is the total count of no of the output, negative outputs. And Pk plus Nk is once you have decided that, for example we take shape is equal to C, what effect we have? Now if we take decision that shape is C, so this whole decision tree is reduced, right? We so this part is not included, we include only C portion of all this decision tree. So this 11 rows is reduced into 1, 2, 3, 4, 5 rows, right? Because we have taken this decision that the shape value is C. So in this reduced decision tree, what will be the number of positive, right? That will be the value of Pk. And in this reduced decision tree, what will be the value of negative value? That is the Nk. So basically if you try to Pk and P plus Nk. So basically if you try to find what this expression means, this expression gives you only what is the probability that this value is selected. After that we simply find the entropy of this reduced decision tree. So if we A takes d number of values, then this decision divide whole values, whole table into d parts, and we sum for those separate d part, we sum those separate d parts of this. That will give you the remainder of A attributes. So let's illustrate this concept using this example. So first we have to find basically in decision tree what is the first root, that is the root of the decision, that is also the first part of the problem. The first part is simply the entropy of H given it is edible, order 1 or order 2. So if we take decision that the order is 1, we have this 3, right? This 3, and if we take decision is 3, then we have these 3 rows, right? And if we then we have to find entropy for H edible given that order is 1 or order is equal to 3. So basically our reduced decision tree is this value and these values. So we have total number of S 3 and total number of N is equal to 3. So entropy can be calculated as, here we see that P is equal to 3 and N is equal to 3. That is important. Every time we have to calculate the number of positive values and every number of negative values. So we have this entropy is equal to 3 upon 6, that is we minus 1. It is simple. Now second option of the second part of the problem is root of the decision tree. So we start making our decision tree. So we have to find again the information gain of the all the nodes. Here we have 3 attributes. What will be the information gain of shape, what will be the information of color, what will be the information gain of the order. Information gain is basically, as we have just discussed, reduced in the uncertainty. That is how we calculate the information. We know the entropy. So if we take particular decision, if we add some information, how much the entropy is reduced, we calculate that to level. For example, if we have the entropy at this level, say, right, and if we take particular decision, then after adding that information we have this entropy this. So information gain is simply this minus this. That is what this formula means, right? So let's start calculating the information. The process is same. I will give you in detail, discuss the number 1. Let's say information gain of shape. So H goal, what will be the H goal? First we have to calculate H goal. In every information we have to calculate H goal. So the H goal will be the entropy of whole decision tree. So we count number of yes 1, 2, 3, 4, 5 and number of no's 1, 2, 3, 4, 5, 6. So basically P is equal to 5 and N is equal to 6 and H goal is basically the entropy binary. I am writing B for short for the binary entropy. So B function you can take it as a function. So 5 upon 11, here this give you the entropy of complete decision tree, complete table, the data table. Now what will be the information gain? So first let's calculate the information gain of shape, right? So shape has this 2 values C, D, 2 value. So take for example we take shape is equal to C. So how this decision our C, we have this 5 rows, right? Now what will be the count for P? 1, 2, we have 2 pk, right? So you understand what is the pk? In the positive decision, in the reduce, we are not including these value D. So we are counting only for C values. So pk is equal to 2 and if you see here it is C which has no value, 3C which has no value. So pk and k is basically 3. So we have a remainder calculated from the formula. Similarly, we can calculate shape D remainder. We have decided shape is equal to C. Now we have decided shape is equal to 3. Now if we see, now the C portion is excluded and we include only the D portion of the table based on this value. So again we count D, here is 3D, so we have P3 in the yes region, and in the no region we have again 3. So we have Pk is equal to 3 and Nk is equal to 3, right. So we have again information calculated. The contribution of remaining entropy, shape is equal to D. So again we have remainder entropy, means that once we take decision for the shape attribute, what will be the entropy? This is given by sum of when shape is equal to C, when shape is entropy for when shape is equal to C, entropy for when shape is equal to D, and we subtract this remainder entropy from the whole entropy of tree and we get this value, right. This is the information gain. Similarly, we can calculate it for, so our in the decision tree, similarly we can calculate for the color, right. So for color, let us see, color is equal to B. So if color is equal to B, again we calculate this Pk and Nk, right, and we have this value. Again similarly we calculate color is equal to W, again we have this value. Now interesting case is color is equal to G and color is equal to W. So when we see the color G, there is, when the attributes color has value G, here it is. So attributes value has color G, it has only one value, right, and it is no, and again U is only one value, it is no. So it is impossible event, so that is, it is certain event, we have an entropy for this event is equal to 0. That is important to note. Therefore the information gain is given like this. Similarly we calculate the information gain of order, again we have, see, it is impossible event, so this part do not consider attribute, and we have this. So based on this 3 value, we see that the order entropy is the largest one, it is the color entropy, and it is the shape entropy. So the root node is the order. So we have basically decided the root of the decision tree will be the order. Right. Again, now once we have decided attribute for order, now what will be the next node, whether it is the shape and color. So now we have separate this order. Now column wise this decision tree, this data table is reduced. Now we have only to consider this 2 column. Among these 2 column, we again carry out whole procedure of calculating the information gain, right, excluding the order. For example, yeah, H goal. Now remember, what will be the H goal? H goal is No, yeah, one thing's the goal is also reduced. The order has we have decided that our tree is order. So order has these three values 1, 2, 3. 1 has from table we can see if we take the order 1 we have only yes. If take order 3 we have only no. Now for 2 we have both yes and no. So these are certain event, right? Now for if order is equal to, then we have yes or no. So we have to decide which factor the shape and color are able to decide what will be the yes or no. Now we need shape and color value to discriminate this decision. So our H goal is also reduced. We are calculating this H goal for edible order is equal to 2, right? So H now the P is equal to 2 now the decision table is reduced into only this part. So we have 2 yes and 3 no's. So our H goal will be 2 by 3, understand this portion. Then we again carry same procedure, and what will we find? The final decision tree will be like we find that color has more value. This is the 1, this is 3, this is 2. Again in color, when once we decide the color, we have this certain event. If color is W is equal to W, then it is yes. If color is equal to green, then it is no. Again color is equal to U, then it is no. And if color is B, again we have 2 number of yes and no. Then we need another node shape. No, if shape is C, it will be yes, and if shape is D, it will be no. This is our the final decision tree. Okay.